I am Dr. Pushpal Ghosh, working as an assistant professor in Department of Chemistry, Dr. Odyssey Center University. Today we will deliver talk on a very interesting topic, an Odyssey of Indian science from ancient to Renaissance. Now I will explain the practical arts, glass, for example, glass and potteries. So Kautilya mentioned that the glass, that we kacha, and differentiate with the crystal. Today we all know what is the difference between the kacha, glass or crystals. Pliny also referred to the glass of India as superior to all others. He further states that the people of India, by coloring crystals, have found a method of imitating various precious stones, beryls in particular. In the drama, famous drama Basavadatta, which is written in 6th century AD, which is mentioned there, that has been made up of glass color like the neck of peacock, glass beads and glass bangles, which was introduced by some foreign tribes like Gujjar and Huns in 8th and 9th century, is also noticed with various colors. Similarly, again potteries was also developed to a great extent, especially we found it in the Taxila, which is around 150 to 280, and paintings is also important. We all know the famous cave paintings at Ajanta, which is around 500 AD, indicates that their knowledge about colors and their sustainability more than 1000 years. Even modern research also indicates the use of nanotechnology in case of Ajanta paintings. Robert Karl, who have discovered fullerene along with two other scientists, Croto and Smale, and awarded Nobel Prize, commented during his visit in one of the Indian Science Congress that earlier Indian craftsmen and painter used nanotechnology in the Ajanta cave paintings. So metallurgy is also very much important, and metallurgy and working of metals also important. Chinese traveller Yuan Shang has left a description of a colossal copper statue of Buddha, which is almost 80 feet in front of Nalanda convent in Bihar. Even Megasthenes mentioned, who came 3rd century BC, about the household use of copper utensils. The famous iron pillar of Delhi near Qutub Minar was built in 4th century AD during the reign of King Chandravarman of Pushkarana, Rajasthan, which is considered as a pillar of victory. It was removed to its present site by the king Anangapala II in or about 1050 AD, when he rebuilt Delhi. This pillar is 24 feet long, 16.4 inch in diameter at the bottom and 12 inch in diameter at the top. The engraved capital at the top is 3 feet 6 inch in length. The weight is 6 tons. It is made of wrought iron without any alloy. This is very important to mark. Specific gravity of the metal is 7.81, while that of pure wrought iron is 7.84, that is very close, and this is supported by research too. Its composition is as follows. For example, in the 99.72% iron, carbon 0.80%, silicon 0.046, sulfur 0.006, phosphorus 0.114, manganese 0. So analysis reveals that possibly the high phosphorus, low sulfur and manganese content has contributed to its strikingly high corrosion resistance. Similarly, iron pillar at Dhar, which is the ancient capital of Malwa, which is much bigger than Delhi pillar, is noteworthy. For example, historian Vincent Smith wrote that while we marvelled at the skill shown by ancient artificers in forging the great mass of Delhi pillar, we must give a still greater measure of admiration to the forgotten craftsmen who dealt so successfully in producing the still more ponderous iron mass of Dhar pillar monument. Similarly, iron beam at Konark Sun God temple is also noteworthy. In addition, dyes and paints, gems, stones, cosmetics, cement they are calling it 3 kind of Vajralepa, metal cement as they are calling it Vajra Sanghata, is noteworthy. Similarly, art of paper making, which came from Nepal around 1000 AD, likewise soaps, cosmetics also flourished. Now I will explain one is a very important area transitional period, which is referred as 800 AD to 1100 AD. Now, Brinda and Chakrapani, two medicinal treatises, which is one is Siddha Yoga by Brinda 975 AD and 1000 AD, and Chakradatta by in 1050 AD by Chakrapati Datta are noteworthy. Both of them mention great alchemist Nagarjuna as authority and followed closely the footsteps of Charaka, Sushruta and Bhagavata. Most importantly, they started use of mercury along with other metals as a constituent of medicines. For example, they have noted a preparation known as Parpati Tamram has been described as follows: sulfur, copper and the pyrites are to be pounded together with mercury and subjected to a roasting in a closed crucible, and the product thus obtained to be administered with honey. Sulfides of copper and mercury are obviously produced by this operation. So, sulfides of mercury constitutes the main ingredient of another preparation called Rasamrita Churnam. For this, 1 part of sulfur and half of this weight of mercury are to be rubbed together. This is to be administered with honey and clarified butter. Now, another important period is Tantric period, which is now referred as 700 AD to 1300 AD, and Indian alchemy achieved its highest peak in this period, because the ultimate goal of the life according to Hindu philosophy and religion is to gain beatific experience of the divine in human nature. According to Zimmerman in his book Hindu Medicine, Tantric cult is characterized by a curious admixture of alchemical process in one hand and grotesque, obscene and sometimes revolting rites on the other, all centered around the worship of Lord Shiva and his consort Parvati. At the same time, in this Buddhist tradition, it is Bodhisattva or Avalokiteshvara as the revealer. So, two distinct classes of tantras, one is Brahminic and Buddhistic are there. So, one of the most famous alchemists of this period is Nagarjuna, who is like Sachin Tendulkar of cricket, who was a Buddhist by faith. He wrote famous book Rasa Ratnakara, Kaksaputa Tantra and Arogya Manjari. There are other many, but these are three important. Importantly, feature of his work, some chemical processes are discussed in the form of a dialogue between the Salibahana and Nagarjuna. Similarly, exchange of chemical knowledge is noticed between Ratnaghosha and Mandapiya. In Rasa Ratnakara, we find recipes of number of mercurial preparations as well as descriptions of processes and apparatus. So, we are seeing that mercury now is being used as metal. Another important treatise is Rasarnava, which is a Brahminical tantra of Shaiva cult. Here also emphasis is given on mercurial preparation. In Rasarnava, mercury is described as a divine origin, being the seed of god Shiva or Hara. In a similar manner, mica has been defined as a seed of goddess Gauri, the consort of Shiva, and the combination of two is hailed as destructive of death and poverty. Other medicinal treatises in this period are Rasa Hridaya by Govinda Bhagavat, who wrote this book by the request of Kiratland, that is near to modern Bhutan at 11th century. Rasendra Chudamani by Somodeva, it is in around 12th to 13th century. Rasa Prakasha Sudhakara by Jasodhara. Rasakalpa is a part of Rudramala Tantra, belong to this period. Rasa Chintamani by Madanta Deva. Dhatu Ratnamala, which is very important, which deals with metallurgy, is also very important text for the science of metallurgy in this time. Similarly, Tantric treatise from Tibet is also noticed. Among all this, Rasa Ratnakara of Nagarjuna was masterpiece. Here he developed the metal based, especially mercury minerals, amalgam based medicines. Even he developed extraction of various metals like zinc, copper, gold, mercury from minerals. Even he invented procedure of dissolution of diamond and other metals at that time. This is really significant. So, Somadeva in his book mentioned function of many apparatus. For example, one is Dula Jantram or Sebdani Jantram, Patana Jantram like distillation apparatus, and Deki Jantram, Bhaluka Jantram like sand bath in modern days chemistry lab. And you can find this picture here. These are the pictures of different kind of machines they have used. So, there are important contributions in other fields. For example, Aryabhatta, who came around 476 to 550 CE, was the first of the major mathematician, astronomers from the classical age of Indian mathematics and Indian astronomy. His works include mainly the Arya Siddhanta. At the age of 499 CE, he was almost 23 years old. And in Arya Siddhanta, he explicitly mentioned of relativity of motion. He also qualified as a major early physicist. His notable ideas was explanation of lunar eclipse and solar eclipse, rotation of earth on its axis, reflection of light by moon, sinusoidal functions, solution of single variable quadratic equation, value of pi correct to 4 decimal places, diameter of earth, calculation of the length of the sidereal year. Another important mathematician is Brahmagupta. He was also around 668, and he was also, along with mathematician, he was an astronomer too. He is the author of 2 early works on mathematics and astronomy, and he correctly established the doctrine of Brahma, which is called around 628, a theoretical treatise. And in addition, in another book, he wrote many practical texts. Brahmagupta was the first to give rules to compute with zero. The text composed by Brahmagupta were in elliptic verses in Sanskrit, as was common practice of Indian mathematics. As no proof is given, it is not known how Brahmagupta's results were derived. And next important person is very much important, Varaha Mihira, also called somebody called Varaha or somebody called Mihira, was an ancient Indian astrologer, astronomer and polymath who lived in Ujjain, Madhya Pradesh. Varaha Mihira's most notable works were the Brihat Samhita, an encyclopedic work on architecture, temples, planetary motions, eclipses, timekeeping, astrology, seasons, cloud formation, rainfall, agriculture, mathematics, gemology, perfumes and many other topics. The chapters of Brihat Samhita and verses of Varaha Mihira were quoted by the even Persian traveller and scholar Al-Biruni. Now, Varaha Mihira's main work is the book which is called, we can call it Pancha Siddhantika, that means treatise on the 5 astronomical canons dated 575 AD, which gives us information about older Indian texts which are now lost. The work is a treatise on mathematical astronomy and summarizes 5 earlier astronomical treatises by 5 authors, namely the Surya Siddhanta, the Romaka Siddhanta, Paulisha Siddhanta and Vasishtha Siddhanta. Now, another important personality in the medieval time is Bhaskara, which is known as called Bhaskaracharya. He was also Indian mathematician and astronomer. He was born in Bijapur in Karnataka, and Bhaskara and his works represent a significant contribution to mathematical and astronomical knowledge in the 12th century. He has been called the greatest mathematician of medieval India. His main work was Siddhanta Shiromani. In Sanskrit, in English it will be Crown of Treatise, is divided into 4 parts called Lilavati, Bijganita, Grahaganita and Goladhyaya, which are also sometimes considered 4 independent works. These 4 sections deal with arithmetic, algebra, mathematics of planets and spheres. So, Bhaskara's work on calculus predates Newton and Leibniz by over half a millennium. He is particularly known in the discovery of the principles of differential calculus and its application to astronomical problems and computations. While Newton and Leibniz have been credited with differential and integral calculus, there is strong evidence to suggest that Bhaskara was a pioneer in some of the principles of differential calculus. He was perhaps the first to conceive the differential coefficient and differential calculus. There are many ancient universities, for example, Nalanda University around 427 to 1197. It was devoted to Buddhist studies, but it also trained students in fine arts, medicine, mathematics, astronomy, politics and the art of war. The center had 8 separate compounds, 10 temples, meditation halls, classrooms, lakes and parks. It had a 9-story library where monks meticulously copied books and documents so that individual scholars could have their own collections. It had dormitories for students, perhaps a first for an educational institution, housing more than 10,000 students in the university's heyday and providing accommodations for 2,000 professors. Nalanda University attracted pupils and scholars from Korea, Japan, China, Tibet, Indonesia, Persia and Turkey. A great fire wiped out the library of over 9 million manuscripts, and at the beginning of the 12th century, the invader Bakhtiyar Khalji sacked and destroyed this university. Another important university was Takkasila University, which is 5th century BC to 5th century AD. Takkasila is described in some detail in later Jataka tales around the 5th century AD. It became a noted center of learning at several centuries before Christ and continued to attract students until the destruction of this city in the 5th century AD. Takkasila is perhaps best known because of its association with Chanakya. The famous treatise Arthashastra by Chanakya is said to have been composed in Takkasila itself. Chanakya or Kautilya, the Maurya emperor Chandragupta and the Ayurvedic healer Charaka studied at Takkasila. Other universities were Udantapur in Bihar 550 to 1040, Somapura in Bangladesh, Bikrampura also important. Now I will explain how this scientific spirit or scientific temper declined in India. In ancient India, the useful arts and sciences, as distinguished from mere handicrafts, were cultivated by the higher classes. There were 64 kalas or art like Suvarna Pariksha, Dhatubada, alchemist, coloring and piercing metals, extraction and preparing medicines were considered as art. In the Vedic age, the rishis or priests did not form an exclusive caste of their own, but followed different profession according to their convenience or natural taste. But all this was changed when priestly class reasserted their supremacy on the decline or the expulsion of the Buddhism. The caste system was established de novo in a more rigid form. For example, according to Sushruta, the dissection of a dead body is a sine qua non to the students, but the very touch of a corpse, according to the new system, is enough to bring contamination to a sacred person. So, shortly after Bhagavata, we found the handling of a lancet, that means dissecting of a body, was discouraged. So, the so-called kalas, that means 64 kalas which I mentioned, and the people who practiced it and which was respected earlier are not respected so high, and it became hereditary. In addition, barbaric attack and destruction of the higher educations institutions like Nalanda, Bikramshila, Udantapuri made the thing worse. Libraries were torched. Monks or teachers are either killed or fled to Tibet or Deccan. Similarly, British occupation and their education policy harmed scientific temper a lot. Earlier, almost every village, almost that time 7 lakh villages were there in India, there are schools and people despite any caste studied there. In this regard, education policy by Macaulay, we all know about it, in the year 1835 is noteworthy, where the colonizers introduced English language based education system, and only privileged class of the society can avail that. So, in one stroke they discarded total Sanskrit knowledge system or traditional knowledge system which is flowing in India for 5000 years, which contains the treasure of knowledge in all branches, and suddenly majority of Indian become uneducated and illiterate with respect to the new education system launched by the Macaulay. For all those reasons, Mother India was rendered morally unfit for the birth of Boyle, Newton, Lavoisier and Dalton, and their very name was all but expunged from the map of the scientific world for a time. In the second part of this lecture, it will be shown how Indian science again resurrected on the onset of 19th century and Renaissance. Thank you very much for your kind attention. Jai Hind.